Good morning, welcome to the class. Today we're going to go over what we have learned so far, and tomorrow we'll do an in-class test. So first of all, we have learned some basic concepts of probability, right? First of all, some basic concepts of probability. You need to be able to tell what is a sample space. What are sample points? And also, you need to be able to draw a Venn diagram for a specific experiment, as well as tree diagram. Okay, for example, you can use an experiment of tossing a coin twice to illustrate these concepts. If you toss a coin twice, sample space is all the possible outcomes, right? Which are the set containing H, T, and TT. So the elements in this set is called the sample points, right? And for Venn diagram, usually we'll use a rectangle to denote the sample space and use some points to denote the sample points in the sample space, right? This is called Venn diagram. And for tree diagram, first of all, we have a starting point. And for the first toss, you can have two different outcomes. So this is our first toss. If you toss an H, if you toss a head, it will land on head. If you toss a T, it will land on T, right? And for the next step, you can also have two outcomes. Again, if you toss an H for the second toss, you will have a final outcome as HH. And following the same principle, you can also have a final outcome of HT, TH, and TT. This is called a tree diagram, right? All right, next is how do we define probabilities? So there are three common methods to define probabilities. First one is called classical method, right? Classical method from which you get theoretical probability. So in this method, the probability is defined as a ratio between number of sample points in this event over the number of sample points in the sample space, right? Second method is called relative frequency method. And using this method, we can get experimental probability. Okay, this method states that the probability of an event A equals F over N, where N is the total number of experiments that we conducted. Fa is total number of times that event A appeared, right? Okay, so there is another method called subjective method. Okay, so in this method, we estimate the probability of an event based on our past experience and subjective choice. Okay, as long as the probability number is within 0 and 1, it can be treated as a probability. Okay, any questions? All right, next we have learned set and their relations and operations. Okay, so first of all, let's see set relations. So what types of relations we have learned? First of all, you should know what is a subset, what is a superset. Subset and superset. What are these concepts? And common symbol to denote subset and supersets are these. A is a subset of B, right? And this is A is a proper subset of B. And if B is a superset of A, B is a proper superset of A. We use these symbols to denote subsets and supersets. Second, we have learned that a relationship is called equality. So equality means if A equals B, this is equivalent to A is a subset of B and B is a subset of A. Okay, and third relation is called mutually exclusive. So in this relationship, we call A and B are mutually exclusive is equivalent to the intersection between A and B is empty set, or the probability of the intersection of A and B is 0, right? Okay, so let's say A and B are mutually exclusive is equivalent to A intersect with B is an empty set. And this is also equivalent to the probability of A intersect with B is 0. So all these three statements are equivalent. Okay, any questions regarding set relations? No? Okay, next let's have a look at set operations. So what types of operations we have learned? First of all, we have learned union, right? A union B is a new set that contains the elements belong to A or B, right? Usually we can denote this by these signs. Next, we have learned intersection. The intersection between A and B can be denoted as A intersect with B or A and B, or sometimes AB. These are all intersection between A and B. So A and B is a new set that contains elements belonging to both A and B, right? This is called intersection. Next, we have learned the minus sign, right? So A minus B is defined as A intersect with B complementary. So this is a new set containing all the elements belonging to A but not to B, right? Okay, last we have learned complementary, which can be denoted as A prime, A bar, or A C. All of these mean complementary, which is the universal set minus the set A, right? Or sometimes we use the letter S. S is called universal set or sample space. Okay, and next, the next key concept is called conditional probability. First of all, the probability of A given B is defined as a ratio, right? Between the probability of A intersect with B over the probability of B, right? Also, you can denote it as a multiplication form, which means the probability of A intersect with B equals PB times the probability of A given B, right? And also, the probability of B given A, according to the definition, is the probability of A intersect with B over the probability of A, right? And if we put PA to the left-hand side of this equation, we can get the probability of A intersect with B equals the probability of A times the probability of B given A. These are the commonly used forms of the probability, conditional probability, right? Okay, next we have learned total probability formula. Total probability formula states that the probability of event A comprises of two parts. First part is probability of B times the probability of A given B, right? Next, plus the probability of B prime times the probability of A given B prime, right? This is in the case of two events. Total probability has this form. Okay, so next we learned Bayes' theorem. Which states that the probability of A given B can be expressed by the following equations. All right, any questions? Okay, next we have learned some common counting techniques, right? Common counting techniques. Okay, first of all, we have learned rule of product. So in rule of product, it states that if a task involves k steps, and for each step we have M1, M2, Mk different methods. The total number of ways to complete the task is M1 times M2 times etc. times Mk. This is the total number of ways to complete the task, right? And second, we have learned rule of thumb. Rule of thumb states that if a task has only one step, but for this step we have k different methods. For the first type of methods, we have M1 sub-methods to finish. For the second method, we have M2 sub-methods to finish. And for the case type of methods, we have Mk different sub-methods. And then the total number of methods to complete the task is to add all these numbers together. Okay, any questions? No? Okay, let's see. The next one is called permutations without repetition. Or it also called sampling without replacement. Okay, in this model, we have a collection of n distinct elements. Task is to choose R out of n and line them up in an order, right? Note here R is within 0 and n. The total number of ways to do this task is PNR. PNR is called permutations without repetition. And PNR can be calculated by n factorial over n minus r factorial. Okay? Any questions? No? Okay, next is permutations with repetition. Okay, so sometimes we also call it sampling with replacement. And in this model, again, we have collection of n distinct elements. And task is to choose r elements out of the n elements, right? And line them up in an order. But for each time we pick the element, we replace the collection with the same elements we pick. That means the container always contains the same n distinct elements, right? So note here, there is no upper limit for R, but there is a lower limit, which is 0, right? The total number of ways we can complete this task is n to the r's power, right? Okay, any questions? No? Okay, let's see the next model. Next model is called a full permutations on a multiset. So first of all, you need to understand what is a multiset. What's the difference between a multiset and a set, right? In a multiset, we can have some identical elements. Okay, so this model states that suppose we have a collection of some elements, and of these elements, there are unidentical elements. And n2 number of another type of identical elements, etc. till n are identical elements, right? And the sum of these elements is n. Okay, and then we pick n elements from the container and line them up in an order. And the total number of ways we can complete the task is n factorial divided by n1 factorial, n2 factorial, etc. until nr factorial, right? Note here that sum of n1, n2 until nr is n. Okay, any questions? No? All right, let's see the next model. Okay, next counting technique or counting models is called combinations without replacement, combinations without repetition. Or sampling without replacement. Okay, so this model says that suppose we have a collection of R elements, n distinct elements. And the task is to choose R elements out of the n. Note that R is within 0 and n, right? And total number of ways we can do this is called CNR, which can be calculated by PNR over R factorial and equals n factorial over n minus R factorial and R factorial, right? This is called combinations without repetition. Any questions? No? Okay, next counting technique is called combinations with repetition. Or sampling with replacement. Okay, and this model states that if we have a collection of n distinct elements, and the task is to choose R out of n, and for each choice, we replace the container with the same elements. So note here again, there is no upper bound for R. There is only a lower limit, which is 0, right? The minimum value of R is 0. Okay, so in this case, the total number of ways we can make the choice is C n plus R minus 1 R, right? Okay, any questions? Okay, don't have any questions. Let's have a look at the last model. Last model is called large collection assigned to small collections. So let's say large collection assigned to some small collections. Okay, so in this model, suppose we have a large collection of n distinct elements. and we want to assign them to different R small collections. And the sizes of the small collections are N1, N2, etc., and NR. Okay, these are called R smaller collections. So note here, N1 plus N2 plus etc. plus NR equals N. Okay, so the total number of ways we can do this is N factorial over the product of N1 factorial, N2 factorial, dot, 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 until NR factorial. Okay, any questions? Okay, next we have learned probabilities using counting techniques, right? So let's say number 9, probabilities using counting techniques. So one of the reasons we learned 8 different counting techniques is to calculate the theoretical probability of an event, which is defined as number of sample points in this event divided by the number of sample points in the sample space, right? So we can use different counting techniques to calculate the number of sample points in these two sets. Okay. And also we have learned some trivial concepts which called odds in favor of A. Okay, so for an event, the odds in favor of A is defined as the probability of A over the probability of A complementary. And the odds against A is defined as the probability of A complementary over the probability of A. Okay, just remember these two definitions. Okay, any questions? No? Okay, let's see the next one. Next, we have learned Pascal's triangle. So what is a Pascal's triangle? Pascal's triangle is a series of numbers, right? From row 0 to from row 0 and onwards, right? So we can write it like this. Any number in the next row is the sum of the two numbers on the shoulder in the previous row, right? 1, 3, 3, 1. And 1, 4, 6, 4, 1, right? You can write it infinitely. Okay. And these numbers correspond to combination numbers. So in row 0, this is C00, right? For row 1, this is C10 and C11. Next row we have C20, C21, and C22. Next we have C30, C31, C32, and C33. Next we have C40, C41, C42, C43, and C44, right? Again, you can write indefinitely. So this is called row 0 and row 1, row 2, and row 3, row 4, dot, dot, dot. There are infinite rows, okay? This is called Pascal's triangle. Okay, next, we have learned binomial formula. Which is stated as the sum of xy raised to the nth power can be expanded as CNN x and y zeros plus Cn n minus 1 x n minus 1 y 1 plus Cn n minus 2 x minus n minus 2 and y2 plus dot 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 plus Cn1 x1 y n minus 1 plus Cn n plus Cn0 x 0 y to the nth. Okay, this is called binomial formula. And if we let this applies to any number for x and y, right? So if we let x equals 1 and y equals 1, this formula becomes 1 plus 1 raised to the nth power equals CNN plus CNN minus 1 plus CNN minus 2 plus dot 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 plus Cn1 plus Cn0. Okay, this is another useful conclusion, which is 2 raised to the nth power. Okay. All right, any questions? No? Okay. Don't have any questions, you can take a 10 minutes break. Please return in 10 minutes, okay? And after that, we'll do some exercises. Okay, welcome back to the class. Now let's take some practices. Okay, first, first question. Okay, I'll write it here for you from a group. Okay, from a group of 7 men and 6 women, 5 persons are to be chosen so that at least 3 men are there. In how many ways can it be done? Okay, I'll give you 5 minutes to think about this question. Okay, have you finished? So how do we approach this problem? First of all, we can draw a diagram to help us understand this question, right? So we have a group of 7 men and 6 women, and the task is to pick 5 persons from these 12 people, from these 13 people, right? The requirements are at least 3 men are there. So this means we can have 3 men plus 2 women, right? Or we can have 4 men plus 1 woman. Or we can also have 5 men plus 0 woman, right? There are 3 options. For the first option, how many ways we can do this? So for the first option, there are 2 steps, right? First step is to pick 3 men out of 7. Second step is to pick 2 women out of 6. So according to the rule of product, we need to multiply these 2 numbers together, which is 35 times 15, right? Next, if we pick 4 men plus 1 woman, okay, again, according to the rule of product, first step is to pick 4 out of 7. Next step is to pick 1 out of 6, right? So for the second option, we have 35 times 6 number of ways. How about the third one? Third one is to pick 5 out of 7. Second step is to pick 0 out of 6, right? So this is 21 total number of ways. So the total number of ways we can complete this task is 35 times 15 times plus 35 times 6 plus 21, right? Okay, so let's put all the numbers together, which is 35 times 15 plus 6 plus 21, which is 35 times 21 plus 21, which is 36 times 21. Oh, this is 7, 5, 6. This is the total number of ways we can complete the task, right? Okay, let's see another example. Question 2. In how many ways can you choose one or more candies from 8 different candies? Okay, again, I'll leave you 5 minutes to think about this question. All right, any ideas? In how many ways can you do this? We have 8 different candies, right? Total number of ways you can do this is you can choose any one from the 8 candies, right? And you can also choose any 2 from the 8, or any 3 from the 8, or any 4 from the 8, any 5 from the 8, and any 6 from the 8, or any 7 from the 8, or choose them all. That means any 8 from the 8, right? So the total number of ways to do this task is to add all the numbers together, right? This is the total number of ways we can complete the task. So how do we calculate this? Remember that Cn plus Cn minus 1 plus dot 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 plus Cn0. This equals 2 to the n's, right? And if we put this term to the right hand side, that means, okay, by observation that if we put this term to both sides of the, okay, if we add this term, this is actually an example of this formula with n equals 8, right? So let's say that 1 n is 8. We have C88 plus C87 plus C86 plus dot 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 plus C82 plus C81 plus C80 equals 2 to the 8th, right? So note that we only want this part. So that means C88 plus C87 plus dot 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 plus C81. We only want this part is 2 to the 8th minus C80. C80 is 1, right? And 2 to the 8th is actually 2 to the 4th and then to the twice, right? Which means 16 to the twice, which is 256 minus 1 equals 255. So there are 255 number of ways we can complete the task. Okay, all right, any questions? No? Okay, let's see another example then. Question 3. Question is, what is the total number of divisors of 2, 3, 1, 0? Okay, what is the total number of divisors of 2, 3, 1, 0? For example, 2 is one of the divisors of this number. Okay, so if we use a number to divide this number and the remainder is 0, that means this number is a divisor of 2310. So the question is, what is the total number of divisors of the number 230? Okay, again, I'll leave 5 minutes for you to solve this question by yourself. Okay, have we finished? Okay, we can approach this problem like this. First, we can find all the prime factors, right? So first, let's find all the prime factors. So what are the prime factors? Prime factors is a prime number and of course is a divisible factor of this number, right? So note that 2310 can be divisible by 2, which is 1155. Then we try 2. 115, of course, cannot be divisible by 2, but can be divisible by 3, right? And the result is 385. Again, 385 cannot be divided by 2 or 3 again, but it can be divisible by 5, which leaves us 77. And 77 cannot be divisible by 2, 3, or 5, but can be divisible by 7, which give us 11, right? And now we can see that 2, 3, 5, 7, and 11 are all divisors of 2310. And also they are all prime numbers, right? So we factor 2310 to 2 times 3 times 5 times 7 times 11, right? We factor this number into a product of 5 prime factors. And now we can consider it as if we pick any one of the prime factors, that number is of course a divisor of 2310, right? Or if we pick any two numbers and the product of that two numbers is also a divisor of 2310, right? Or if we pick any three numbers from the prime factors, the product of that three numbers is again also a divisor of 2310, right? Okay, so following this principle, total number of divisors is, for example, we pick 1 from the 5 plus number of ways we pick any 2 from the 5 and we pick any 3 from the 5 or pick 4 from the 5 or pick 5 from the 5, right? From pick 5 from the 5 means the number itself, right? But don't remember that the number 1 is also a divisor. So that means we pick 0 from the 5, right? So if we add all the numbers up, this is the total number of divisors of this number has. This is, according to the binomial theorem, this is 2 raised to the 5th power, right? Which is 32. Okay, so now we can make the conclusion. The total number of divisors of 2310 is 32. Okay, have a look at this question. Anything you want to ask? All right, if you don't have any questions to ask, the rest of the time is for you to go over all the contents in Unit 1 and get prepared for our next test. Okay? If you have any questions, you can ask here.